This is my two-story freight elevator. It uses relay logic and it is copied from an actual elevator made by J&E Hall in 1955, and the logic circuitry is similar to the original. We'll run it. We go up and you'll see that as we approach the second floor it will slow down. It's now running at half speed and it gets to the top and it stops. The same with the down direction. Coming down. It slows to half speed. And it stops. That's the basic operation of the elevator. If one of the doors is left open, like that, and we try to call the elevator to either floor, the bell rings. This is the bell at the top. Here's the bell. And of course the elevator won't run. If we close the gate, then the elevator will run. The speeds are controlled by a differential gear. I'll get into that in detail later. It has a counterweight, as you would expect, and the counterweight of course balances the weight of the cage itself. Here you can see the differential gear more clearly. That's the basic elevator, and now I'll show you the different components. In order to show the machine room area at the top, I have to model off the bench and drop it down a bit because it's too high. I can't get the camera over the top. But here's the relay rack. We've got a relay for the brake, the slow and fast speeds of the cage. The fast slow controls those two relays, a relay for the bell, and the up relay requires 6 contacts, so I've had to use 3 relays for that, and the same with the down relay consists of 3 relays. Here's the bell, just a normal simple bell. We can show it in operation. We'll open a door and we'll try to call an elevator, and instead the bell rings. This elevator is very simple, and if somebody has left a gate open and you want to use the elevator, you press the button, the bell rings, and then you have to go up and close the gate yourself. As simple as that. It is just a freight elevator. We have 2 motors. The original had a double wound 3-phase motor. Of course I don't have one of those. So I use 2 motors and this differential gear. When it's going fast, both motors run, and you'll see that when it slows down, the right hand motor, which is the fast motor, stops, and so only the left hand motor, which is the slow motor, is running, and therefore the elevator runs at half speed because of the differential gear. I've also made a brake, which is here, It doesn't actually brake the motor, but the operation is the same as the brake in the original elevator. You'll see that the jaws open when the elevator is running. When the lift stops, the jaws will close again. The same way as in the original elevator and lots of others, the speed is controlled by these roller switches that are mounted on the side of the cage, and the switches are operated by these cams. These are mounted to the lift shaft itself. So I hope I can show you here. This long cam is for the slow speed and the short one is for the stop. So when the cage comes up, you'll see that the slow roller switch is engaged and it slows down, and then the stop switch is engaged and it stops. Similarly on the way down, the slow roller switch will engage there, it slows down to half speed and then it will stop. The differential gear combines the output of the two motors to the large sprocket wheel. When both motors are running, it will go at full speed, and when only one motor is running, it will go at half speed. So we'll bring the cage up and you'll see both motors are running and the drives are combined to the big sprocket wheel. When it slows down, only the left-hand motor is running and the differential absorbs the motion or the lack of motion of the right-hand motor to reduce the speed by half. We'll go down again, and here now we'll show you this side of the differential. This side is still running, the other side is stopped. I don't think there's anything else to show. So thanks for watching.